Guys, welcome to my YouTube channel Genetics. So guys, as we have started our LangChain full course, so in till now we have completed almost all the components of LangChain and along with the rack, and we have also seen our rack architecture, and we have seen all the components of rack like document loader, vector store, embedding models, retriever, everything, right? So this is the right time to see a end-to-end project on rack so that you can get more clarity and you will get to know how actually our RAG application gets built. Okay, so let's get started. So guys, first of all, I have created one new repository in my GitHub account. So I have named this RAG ML chatbot, and now in order to clone this kit in our local, so I am copying this URL and I am cloning over here. So I have to run git clone and I have to paste the URL. So it's cloning. Now it's cloned. Now see, this is our folder, project folder. Okay. So I'm opening it in my VS Code. So this is our code editor. Guys, in this project, what we're gonna do, we'll create our project in modular structure. Okay, because in industry level, most you have to always use modular structure. So instead of creating a normal project, we'll use our complete modular structure project. Okay, so first of all, in order to create our project, as usual, we have to create our environment, right? Virtual environment. So I'm creating, let me open command prompt. Now I'm creating my virtual environment. I'm using 3.10 Python version -m -emv, and this is my virtual environment name. Okay, so let's create it. So our virtual environment has been created. Okay, so next what you have to do, we have to create our requirement files, right? Requirements .txt file. Okay, so in this requirements we have to install this dependency. Okay, Flux we have to use for creating our backend. Okay, LangChain OpenAI, that is LLM model, LangChain community, python.env in order to load our env file, sentence transformer. In this project, we will use sentence transformer, our embedding model. Okay, PyPDF to load our PDF file, and FAISS CPU for our vector, FAISS as a vector store. Okay, so these are requirement files. So let's install it first. So first of all, we have to activate our virtual environment, right? So mynv script activate. Now our virtual environment has been activated. Now in this virtual environment, we have to install our requirements file. Okay, pip install -r requirements.txt. So our requirements is getting installed. Okay, so let it be installed first. Okay, so our requirements has been installed. So till now, whatever we have done, let me push in GitHub. Okay, and before that, let me write. We don't want our virtual environment folder to be pushed in our GitHub, right? That's why we have to mention about this folder in our git ignore file. So let's make it my env /. So see, now it gets untracked. So we don't want our virtual memory folder to be pushed in our GitHub, right? It is not necessary. That's why we have mentioned it in our git ignore file and it gets untracked. Now let me push till now whatever we have done in our GitHub, right? So git add git commit -m requirements added. Git push origin mail. Now everything get pushed. Okay. So let's clear it. Now what we have to do? We have to create our .env file where we can implement our all the API keys, right? So we have to create .env file. Here we have to mention our OpenAI API key, right? So guys, you all please put your own OpenAI API key over here. You don't have any, if you don't have OpenAI API key, then you can use Grok Grok API as well. So both will work. Or Google API you can use, anything you can use. Okay. So let me put it. Okay, so I have included my OpenAI API key in .env file. Okay, so now we'll start our project. So guys, we will use modular structure definitely, but before that, it would be always preferable or better way to use a project that you can create your project in Jupyter file fast. Okay, so it will be easier to create your project in a single file, so you can create it more easily, and once it is done, then you can convert your Jupyter notebook code in your modular coding, right? So before starting our modular coding, we create our one experimental Jupyter notebook. Okay, so let me write experiment. Okay, .ipynb. Let me select my kernel. Now it is asking me to install the IPY kernel, right? So let me install it. So kernel has been installed. You have to run our Jupyter notebook, right? So it is installed. So let's start our coding. So first of all, we have to import. Sorry. We have to import LangChain OpenAI, Chat OpenAI in order to use our LLM model. Okay. For accessing our PDF file, we have to use PDF loader and directory loader. Okay. For to split our document, we have to use recursive text splitter, and Hugging Face, we are using Hugging Face embedding model. That is why we have installed our sentence transformer, right? Okay. So in order to use Hugging Face embedding models, we have to install our sentence transformer dependency. Okay, and vector database 5. I will be understanding everything because in previous classes I have already shown everything: document loader, document splitter, embedding model, vector document, everything, right? So I hope you guys understand everything. So let's run it. So it's get run. Okay. So next is we are creating our one function. Okay, as we are we will build our modular code. So always in industry we have to always use function type coding, right? So in order to use our document loader, we are creating this file loader function, and within this I am passing my path, and we are using loader equal directory loader, and within this we are passing this path globe equal to .pdf, means all the PDF files, and file loader class equal to PDF loader, and document equal loader.load, and I'm returning these documents. Okay, so I've seen everything. If you are not seen now my previous classes on document loading or on everything, so I'll give the link in my description box, so please go and see the videos. Okay, so this is the function document loader function. So let's run it. Okay, now we have to create one variable. Suppose extracted docs equal to, we have to call this function, and within this we have to pass our path. So which path we have to pass? We have to create one folder, suppose data folder, and within this we have to keep our one PDF file. Okay, so I have a one PDF file. This is hands-on machine learning.pdf. This is one of my PDF file that I have put in my data folder. Okay, now I have to mention this path. Okay, data. Okay, and okay, so all the file, whatever file is present in this data folder, all the .pdf file, whatever .pdf file is present in this data folder, that will be extracted. Okay, now all the file has been extracted. Now after document load, we have what we have to do? We have to chunk our document, right? So for chunking, this is our function. Chunking data, we are passing our data, speed data, recursive speed text splitter. I have shown in my previous class in text splitter classes, so you can check in my channel. Okay, chunk size 500, chunk overlay 50. Speed data dot speed document, we are passing our data and returning chunk data. Okay, so these are function. So using this function, chunking data, I'm calling this function, and within this I have mentioned data, so I am passing my extracted data. These are our original data, so I am passing this data in my chunking data function and put it in a variable that is chunk data. Okay, now our document, this document hands-on machine learning PDF file, this document get chunked, and now let's see what is the length. Now see, after chunking our document, we got 2120 chunks. Okay, so next is, and if you want to see the chunk, any document of this chunk, then you can see using chunk data. Suppose we want to see 40 data. Okay, dot text content. I hope you remember. Now see, this is our 40 chunk. Okay, right? So now after chunking, what we have to do? We have to embed our data, right? So these are function for embedding our data. So this get embedding, this is our function, and we are calling function Hugging Face embedding model. Okay, and this is our model name, and we are returning embeddings. So let's run it. Now our function has been done, and then what we have to do? We have to initialize our embedding, this function, right? And we have to put it in a variable, embedding. Okay, now our embedding gets ready. Okay, let it run first. It's actually embedding our documents. Okay, now we have to after embedding, what we have to do? We have to create our vector store. Okay, so FAISS our vector store. From document, we have from FAISS.from document, we have to pass our document says what is our document? That is chunk data. These are our main documents. So in document we are passing chunk data and embedding, as embedding, we are passing my embedding model. Okay, now let's run it. Okay, so our entire document got stored in our vector database, that is FAISS. Okay, LangChain community vector store, everything got stored over here. Now, after storing our data, what is the next step? Next step is retriever, using retriever. So, using retriever, what we have to do? We have to fetch our similar documents from vector store, right? That is why we use retriever docs. This one docs as retriever, search type similarity, search squared, top 3 documents, right? Output is retriever.invoke and passing what is the supervised machine learning. Okay, and I'm printing our output. So see, we got top 3 document. We got top 3 document. This one, and this one. Okay, so these are our top 3 result. Okay, now what we have to do? We have to send this document to our LLM so that we can get our proper structure output, right? So in order to use our LLM, we don't need to use OS. Sorry. See, OpenAI API key that we have initiated in our .env file. So OpenAI API key os.get env and os.environment OpenAI API key, and we are passing LLM chat OpenAI model chat GPT photo mini temperature 06. Okay, now let's run it. Now our LLM model got initialized. Okay, now we have to import these 3 functions. So what is create stub document chain? One is create retrieval chain. Okay, so let me write the next code so that you can get to understand it clearly. See, first this is a system prompt. We are mentioning our system prompt. You are an expert data scientist assistant of question answering tasks. Okay, used for following places of retrieve context to answer the question. If you don't find any related context, then say that you don't know. Do not give any hallucinating answer of this. Use the 3 sentence maximum and keep the answer concise. Next time context. Okay, so basically these are system prompt. We are telling our system to act as like this. Okay, so we are instructing our system. So these are system prompt, and we are mentioning the context. Basically, what happens whenever retriever retrieves the similar document, whatever retrieve document, all this retrieve document get stored in this context, and this context gets injected to this prompt. That is why we have to use context with this curly brackets. Okay, this is the main funda. Whatever documents gets retrieved by the retrieval, that will stored in this context, and this context will gets injected to this prompt, system prompt. That is why we have to use context. Okay, so using create stub document, what we have to do? Basically, this prompt gets stuffed with our main prompt. Whatever prompt will be given by the user, this prompt will get stuffed by the system prompt. Okay, so that is to stuff this prompt, we have to use create stub document. And whenever we will use this create stub document chain, we have to use this create retrieval chain. Okay, so once I write the code, then you will get more clarity on it. Now see, there is stub chain. What happens? In stub chain, we are passing LLM and chat prompt. So using chat prompt, what happens? So basically, what happens? Retrieve all the documents and put it in context. This context gets injected in this system prompt. Now in this chat prompt, both prompt, system prompt and user prompt is coming over here, and using this stub document chain, both prompts get stuffed together. Okay, before sending it LLM. Once it gets stuffed, then it is sending to the LLM for further processing. Okay, that is why we have to use create stub document. Whenever we have to use this type of context, we have to use create stub document chain. Okay, so our stub chain gets ready. Now we have to use create retrieval chain, and we have to pass our retriever and this stub chain. That's it. Now our chain is ready. Okay, our complete chain is ready. Now we are passing our question. What is machine learning? Okay, so we are putting it in response dictionary. Retriever.chain.invoke. We are invoking our input as question. Okay, and we are passing response equal to response dictionary in answer, because there is a parameter that's answer, and we have to retrieve only answer part. Okay, that is why we are passing answer. Now let's run it. Okay, so let me run this cell. Okay, just a minute, guys. Okay, now see, we got the answer. Machine learning is the field of artificial intelligence for focusing on developing something. Okay, so our model is ready. So what happens when you are user asking any question, what is machine learning? Then based on this question, retriever retrieves the top 3 document, and using LLM we are getting the final answer, structured answer. Okay, so basically this is about rack architecture, how rack working. Okay, now let's ask another question. What is TensorFlow? So everything is same. Okay, I'm changing that only question. Okay, now see, TensorFlow is an open source machine learning framework, blah blah. Okay, so this is how you can ask any kind of question that is present in your own document. Okay, so basically this is our explain file. So now let's create our modular structure. So basically we have to convert our this Jupyter notebook in our modular structure. Okay, so in order to create, first of all we have to create one source file. Okay, source folder. Now in this source folder we can create one file, that is helper.py. Okay, helper.py. In this helper.py we'll put all type of function. Okay, so I hope you understand what's the basic concept of modular structure. Using modular structure, what we can do, we can keep our different of code in different of file. Suppose we have multiple functions, then we can put all the function in a single file. We have different type of prompts, so we can keep all the prompts in a single file, so that whenever we have to we have to make any changes on prompt or function, whatever it is, we can go only that file and changes over there. So we don't have to find anything here and there. Okay, so it gets basically it's become more modular and structured way to write our code. Okay, so using in helper.py we'll put all our functions, whatever use in our code. Okay, another file I would like to create over here, that is prompts. Okay, prompts.py. Okay, and guys, always remember, if whenever we want to use our local folder as any kind of package, I mean local package, then we have to create one file that is called in constructor. Okay, that is dot in underscore init underscore dot py. Basically these are our constructor file. So see, using LangChain OpenAI we are importing chat OpenAI, right? This is one kind of importing function. So whenever we have to import any kind of file in different page, then we have to use you have to create that folder in a local package. Okay, suppose we have to call our prompt.py file in our helper.py file. Then we have to call this in order to call this file to our helper file, we have to create our source folder as a local package. Unless we cannot call it. Okay, so in order to create our folder as local package, you have to initiate this constructor, that is underscore init underscore dot py. That's it. So in our helper file. Now see what happens. We are importing, you can see everything is same. We're just keeping all our function that we have used in our code, in our Jupyter code, that all the function we keeping in a single file. So this is the file loader function, this is the chunking function, and this is the embedding function. We'll keep all these things in a single file. Okay, so our helper file is ready. Now prompts file. So whatever prompts we have used in our Jupyter code, that we have to use in our, that we have to keep in our prompt file. Now see system prompt and prompt file. Okay, everything is same. I'm just copying and pasting over here. Okay, now our helper file and prompt file is ready. Now we have to create one file, that is store.py, that is vector store file. Okay, so now see in order to call our helper file and prompt file, we have to use source.helper. See, from helper.file we have to call file loader, checking chunking data, get embedding, everything. Star means everything. Okay, so if I am to call everything from helper file, then what we have to do? We have to write src.helper import star. Star means all. So from src folder, in src folder there is a file is helper, and from helper we are importing everything, that is start. And that is why we have to make our source file as local package using __it __dot.py file. Okay, so as we have created this file, this constructor file, our source folder get become our local package. So we can call our source folder helper file, and from helper file all the function we are able to call. Okay, that is why we have to use local package. So this is .env, OS, FAISS, and we are loading loading our .env, and these are file. I'm calling file loader and passing my folder where my document is kept. Now these are chunking function. I'm calling this file, and this is the embedding model. Okay, now docs, everything is same. Now our storage also get ready. Okay, now what we have to do? We have to create our backend file. Okay, that is app.py. That is our backend code. Okay, so this is our Flux code. Okay, now see, from Flux we have to import Flux render template request. Okay, from src.helper we are importing only get embedding, LangChain OpenAI, chat OpenAI, create stub, create retrieval, everything is same. Now we are initializing our Flux app. Okay, app equal to Flux _ name load.env OpenAI. These are embedding. We are calling this function and putting it in embedding. Now this is the retriever. Everything is same. Retriever. Now these are base prompt. So these are base prompt. Okay, we are creating base prompt. These are chain. Everything is same. And these are root. App.root / these are / means home page. Okay, now these are first index where we are rendering our chat.html page. Using / means home page, and in home page we are calling our index function, and here we are rendering our chat.html file. Okay, these are first. These are second root, that is /get. We are using method get or post, and here we are passing on message request.form and passing this message response equal to reaction.invoke input equal to message, this one. Okay, and print response. These are kind of little concept you have to you have to have a little concept of Flux. Okay, so if possible in future I will make a video on Flux. Okay, so for the time being you just understand how it writes. Anyways, I'll give this code in my GitHub, and I'll put the GitHub link in my description, so you can copy and paste over here. These are main concept. Your main concept is not understanding the Flux. We are understanding how our application works. Okay, So these are we are printing our response, and these are in our we are porting where our 800 port. Okay, and these are host. This is how we initialized our Flux. Okay, now our backend code is ready. These are backend code. Now, in order to interact, user has to interact with front end page, right? So in order to create front end, we have to use we have to create one file, that is this folder, right? Template. Okay, we are creating one template folder. So within this template folder, we have to create our HTML file. Within this, we have to create our chat.html file, and this is our HTML file. Okay, and we have to create another folder, that is static. Okay, and within this, we have to create our CSS file. Okay, this is your CSS file. So we have created almost everything. Let's try to run our file once. Let's see. Okay, let me first post my code in my GitHub. Okay, before run, and let me post it. GitHub git commit -m. I'm sorry. Git commit -m files added. Okay, git push origin made. So everything gets pushed. Okay, not clear it. Now, in order to run our project, what we have to do? We have to run our backend file. Okay, this app.py file. So once we run it, automatically create our vector store, and it will give one URL in order to run our front end. Okay, so let's run this app.py. So Python app.py. Okay, now let's run it. Now see guys, it got executed, and it is giving me one URL. Okay, so we have to run this URL. So using this URL, we are running our front end. So guys, our front end got executed, and these are front end. And let me ask any question. I'm asking the same question. What is machine learning? And see, we got the result. Basically, the science art of the program and everything. Okay, so these become our Q&A chatbot. Okay, now let me ask another question. What is deep learning? Now see, please give me the answer of deep learning. What is supervised machine learning? Now see, it is giving the answer. So this is our entire chat model. Okay, chatbot. So basically, we have used our own database, that is our PDF file, and from that file, we have created our RAG chatbot. Okay. So I hope guys, you are understanding everything. So you do different type of examples. You can refer any kind of document. You can refer any kind of vector database, and you practice as much as possible so that you can get more clarity on it. So this is how we create our RAG chatbot. Okay. So I think everything got covered in this session. So I'm wrapping up my videos. So guys, if you're liking my videos, please do like and share my videos. And if you are not yet subscribed, then please subscribe my channel. Okay. So thank you so much, guys. Thank you.